Now, when we're trying to define what's going on inside a resistor, we need to talk about what's called its resistivity. Resistivity is kind of like the amount of resistance that a material gives based on the type of material it is. It's kind of the chemical and structural makeup of that material tells you how much it's going to resist um, a given electric current. So different materials will have a different resistivity, and the symbol for that resistivity is the Greek letter rho. It's kind of a curly P. I always think of it as the Philadelphia Phillies P, but it's not quite the same. But it's the Greek letter rho, and the units of that are what we call ohm meters. And so different materials will have different resistivities, and that's something you can just look up to get that value for a given material. So for example, let's say you had a material, so the darker gray on there is our material that has a resistivity rho. The amount of resistance that it has depends on the length of the material. So the longer the resistor is, the more of the material the current has to travel through. So it kind of makes sense that it's a bigger, the longer it is, the more resistance you get. But then you divide by the area. And the way I always think about that is if it's a bigger area, there are more paths. There's an easier way for the current to travel through. It's like a hallway. If the hallway is kind of wider, it's going to be a lot easier to get a lot more traffic through there. In this case, that traffic being the current. So the resistance is the resistivity, which is just a property of the material, times the length of the material divided by that area. And just as an example, and in your textbook there are a bunch of different values of this. This isn't something you have to remember or memorize. If you need them, they'll be given to you. But for example, silver is the natural material with the lowest resistivity. But it's fairly expensive, so generally we choose the next lowest resistivity to make most of our electric circuits out of. So copper is used a lot. Gold people think of as would be a very low resistance thing, but it's actually quite a bit higher. One of the nice things about gold is that it doesn't tarnish, unlike silver and copper. And iron is quite a bit higher, so you don't usually, so iron doesn't conduct electricity nearly as well. Some other things that affect the amount of resistance, we have the length, we have the area. So the longer the length, the greater the resistance. The smaller the area, the greater the resistance. Temperature actually affects it as well. The higher the temperature, generally there's more chaos going on inside of the wire, so there's more resistance. And then the type of material. Silver is the lowest natural resistivity, where you get iron, platinum, lead, things like that are a bit higher in their resistivity. So we'll do this. This will be part of some of the warm-ups this week, just to kind of give you an idea. But I want you to see how resistance depends on the material itself.